This is going to cover the review for the test on Chapter 11, Part 2. I believe it's sections 11.6 through 11.8. Okay, so first of all, looking at section 11.6, I'm on page, I'll focus it in just a second, page 695, looking at number 29 through 39. Okay, good. That seems focused. 29, I'm assuming you have your book open. I'm not going to keep flipping back and forth between pictures of the book and this. It's a parallelogram. I'll just do a rough sketch. These are dotted lines right here, over here to the side. They show us that the height is 10 feet and the base is 12 feet. And this shape is a parallelogram. Again, the dotted lines are not part of the shape. It's just the solid lines. They're part of the shape. And the area for a parallelogram is base times height. So our base is 12, our height is 10. So since we're dealing with area, we would do 12 times 10, which gives us 120. We would say feet squared because we've got to square all the units for area. Number 30, we have the picture of a triangle. It shows a right angle at that spot. That's what that red kind of squarish shape means. So truthfully, it might be easier to think of the triangle this way. I know my numbers are upside down now, but it's probably easy to think about this is the base and this is the height. Or you can even say this is the base and this is the height. It doesn't matter either way because we're multiplying. So the formula for the area of a triangle is 1/2 times base times height. So we do 1/2 times 4.4 times 4.2. Doesn't matter which one you say is the base or the height, but those are the two numbers you need. And when you multiply those together, you get 9.24 centimeters squared. In general, with the area formulas that aren't using pi, it's best to just give me the exact answer because they're not going to be more than 1 or 2 decimal places in general. If you round, I'm probably not going to count off, but if you can give the exact answer, that's great. 31, we're dealing with decorating, it says. We have a trapezoid. So let me go ahead and deal with the shape in its area first. Again, the dotted lines are just to help mark a distance or a length or a height in this case. They're not part of the shape. Only the solid lines, the solid 4 lines, are part of the shape. So let's just start by finding the area of the trapezoid, then we'll look at what else it's asking. So the trapezoid's formula is 1/2 of the height times base 1 plus base 2. And it does not matter which one you call base 1 and base 2 because you're adding them together, so it's the same result either way. But the height is the 3 feet found right here. That's what they're showing with these dotted lines. And these are the two bases. Makes no difference which one you call which. 6 plus 11 and 11 plus 6 both equal 17, so you're good either way. Okay, so 1/2. Not what I thought it would do. Hold on. Oh, I don't have the calculator on this computer. My mistake. Stand by. Okay. 1/2 times 3 times 6 plus 11. Let's see, I can do this. 17 times 3 is 51. 1/2 of 51 is 25.5. So the area of the trapezoid is 25.5 square feet. So that's the area. Now, that's not the final answer, because what they say is Mrs. Jackson wanted to lay tile in the area in front of her fireplace, as shown in the diagram. That's our trapezoid right here. The tile costs $2.99 per square foot. About how much will it cost Mrs. Jackson to tile the area? So we have found how many square feet that area is. Now we need to multiply that by $2.99 to figure out what the total cost would be. So 25.5 is the number of square feet. It costs $2.99 per square foot. So we get a cost of about $76.25. And that's rounded to the nearest penny. Okay, moving over to section 11.7. Now we're dealing with circumference of a circle. So there are two formulas for the circumference of a circle, and which one you use just depends on what you're given. So if they give you the diameter of the circle, you want to use this formula. If they give you the radius of the circle, you want to use this formula. So number 32, they give us the radius, because you look at the picture, that's the distance from the center to the edge. That's the radius. So they'd give us 20 kilometers. So we would use this equation because they gave us the radius, 2 times pi times 20. And that gives us approximately 125.7 kilometers. Notice I'm not squaring this unit because circumference is a distance. It's a length around the circle. It's not an area. So there's no need to square the units with circumference. Area, you do square the units. Circumference, or perimeter, you do not. Now on 33, they gave us the diameter because they gave us the distance all the way across the circle. So in this one, they told us the distance all the way across is 14 yards. So that means we use this equation, pi times d. So the circumference is pi times d, which is 14. The diameter is 14. And when we plug that in the calculator, it tells us it's about 44 yards. Sorry about that. So pi times the diameter. 34, they give us the diameter. So the circumference is pi times 5 1/3. Sorry, I can't pull up the calculator on this computer. But when you're plugging 5 1/3 in the calculator, what you can do is do pi in the parenthesis 5 plus 1 divided by 3. So 5 plus 1/3 or 1 divided by 3 will give you what you need. Or you can just type this in first, and once you get the result, multiply by pi. That turns out to be 16.8 feet. .35, they give us a radius of 13.5. So since it's a radius, we'll use this formula. We'll say the circumference is 2 times pi times 13.5 millimeters. When you plug those in the calculator, you find out that the circumference, the distance around the edge of the circle, is 84.8 millimeters. .36 is our last question about circumference. The first Ferris wheel, which if you didn't know, I just learned this within the past year or so. The first Ferris wheel was built for the World's Fair in Chicago. The Eiffel Tower was built for the World's Fair in Paris. And then they were trying to figure out, when the World's Fair happened in Chicago a few years later, how can we one-up them? So they built the very first Ferris wheel. It had a diameter of 250 feet. What was the distance to the nearest whole foot that riders traveled if they stayed on the ride for 15 rotations? So let's think about what they're saying. Here's our wheel. Its diameter is 250 feet. Now someone would get on down here, but riding all the way around one rotation, that'd be one circumference. So the riders ride one circumference of the circle. So they want us to find out not how much it is to go around once, but to go around 15 times. So the first thing I'm going to do is find the circumference of the Ferris wheel. So they give us the diameter, so we do pi times the diameter. But then that would just tell us how many it is to go around one time. They want us to know how far it is to travel around 15 times. So we now need to multiply that by 15, because we're wanting to know the distance of 15 circumferences, because they're taking not just one rotation around, but 15 rotations around. So it turns out they would travel a total of 11,781 feet if they were to ride the Ferris wheel all the way around 15 times. So again, this gives you the circumference, one ride around, one rotation, then you multiply by 15 to find out how much 15 would be. Okay, 37, we're switching over to area of a circle. The formula for that is A equals pi r squared. On 37, the picture gives us 8 centimeters for the radius, because that's the distance from the center to the edge. So we just plug in pi times 8 squared. So the area, when you plug that in the calculator, you get 201.1 square centimeters. We're back to area, so we do square our units again. Circumference you don't, area of any shape you do. Now the one tricky thing they can do is like on 38, they give you the diameter. Okay, it looks something like this. It's 13.5. And in the calculator, if you want, you can plug in 13 plus 1 over 2 to get what that's equal to, or I should say 1 divided by 2. It's just 13.5. I understand other fractions don't come out that cleanly, like 1/3. You can't plug in 0.3 forever, but 1/2 hopefully knows just the same as 0.5. Okay, but the formula for the area of a circle doesn't have diameter, it has radius. So we have to cut this in half to get the radius, and that will be 6.75. You can do that in the calculator. Just do 13.5 divided by 2. We get a radius of 6.75. So for the area of a circle, this circle in particular, we do pi times 6.75 squared. Because again, we can't plug in the diameter here. There's no diameter in the area formula for a circle, just a radius. So we were given the radius. No, sorry, let me back up. We were given the diameter, the distance all the way across the circle. We cut that in half to get the radius and plugged it into the area formula. So it turns out that circle has 143.1 square inches. That's number 38. Okay, last one, 39. A blueberry pie has a diameter of 9 inches. So we have a diameter of 9 inches. Then they say, what's the area of the top crust? So we're just finding the area of the circle. It's like we're looking at the pie directly from above. Again, they told us the diameter is 9, but we need the radius for the area of a circle, so we cut this in half. You can say 9 halves or 4.5. So we plug this into the area formula. Pi times 4.5 squared ends up being 63.6. Let me try it again. 63.6 square inches.